Fine, Rishabh, please proceed.
Yeah, thank you, sir. So that is the basic working of my model. Now, system architecture is simple, model creation. So using the crawler, I collected the data from internet. I performed data cleaning and trained model using different algorithms. Now, this comparison will be further discussed in result and analysis. I'll get to that in a while. So out of that, the best performance was by BERT model. So BERT is nothing but bidirectional encoder representations transformer. So this algorithm worked very well as yeah, now this I have already actually explained that four submodels are being created, and for each of that, like for racism one, for sexism, for body shaming, for hate speech, based on that we are getting an output, and through softmax layer this is just we are passing it through softmax layer, which is just to convert it into probability from 0 to 1, and finally we are getting the predictions. Yeah, this is the prediction logic which I have already explained, that we are comparing positive probabilities as well as negative. So this further improves the accuracy of the model. And finally, yeah, so
Yeah, sorry to
this,
interrupt, Rishabh.
yes.
Could you elaborate a little bit more about how the threshold values were set?
Yeah, yeah. So the thing is, as the threshold value zero point 0.5 is, we can say it's rather arbitrary, because for any binary classification, we usually use zero point 0.5 value if the data is following a uniform distribution, right? Like if something is racist or not racist, or let me take a simple example. We are predicting cats and dogs. So something can either be a cat or a dog, but there can be another image which is neither a cat nor a dog. So based on that, I use that particular approach and generalize it into this NLP, for this NLP project. So what I am doing is, suppose the my one of my model is saying that the value that this particular comment is discriminatory is suppose zero point 0.6. So it's well and good. Now there's some level of uncertainty here because it's just zero point 0.1 above the threshold, that is zero point 0.5. Now but the model is also giving that the probability that the same statement is not discriminatory is, let's say, zero point 0.4. So in that case, we can say like there's a double checking being performed, that the positive value is above the threshold and the negative value is below the threshold. Then we can conclude that this particular statement is indeed discriminatory. But what happens if the positive model is saying that I'm quite certain, like I'm 70% certain that this is racist, but the same model is also saying that I am also certain with a probability of 60% that this particular statement is not racist. So here the model is contradicting itself. So for identifying such contradictions, we are assigning the value inconclusive to the flag, and then we will print the particular probability in case the model is giving uh, inconclusive tag to a particular comment. So that is the whole prediction logic. And yeah, the threshold zero point 0.5 is rather quite normally used in general, like practical life. So I didn't think much about the threshold value. I know that there are some techniques like cross validation and all, but unfortunately I couldn't use them. So yeah, that's why the value is zero point 0.5, because of general arbitrariness. So,
Yes,
so
yes,
yeah.
fine, thanks. Yeah, you please proceed further.
Yeah, okay. So yeah, data collection methodology. So I have already specified the hashtags. I have used hashtags as the classification, like as a use the help of hashtags for assigning the labels. But the thing is, sometimes hashtags are also like mislabeled. Like some trolls on Twitter can just provide false hashtags, right? So for rectifying that, I also manually I had like roughly 6 months to make this project. So I manually and painstakingly verified each and every label, even after using the hashtag approach, so that it's more accurate. Now, this is the general structure of the crawler. As you can see here, it's mainly using hashtag based filtering. and then multi-threader downloader. So we are basically running multiple parallel threads simultaneously. That way the data was collected fast. Now this is the BERT model. So BERT model has two stages: the pre-training stage and the fine-tuning stage. So here the thing is, like normal transformers, what they do is they read data from left to right. But the groundbreaking thing about BERT model is that it can predict the next sentence as well. Kind of like when we type something on Google, it can tell us like what we are going to write. So that's basically next sentence prediction. Yeah. So here we just convert a sentence to masked form. Mask is basically an encoding that the model uses so that it's easier for it to process data faster. So we are giving in some masked sentences, and when the model is fine-tuned, so we will give it a particular question, and it can either generate a paragraph. But here I am not focusing on the generational aspect, so I fine-tune the model in such a way that instead of generating something, it just gives the value 0 or 1. So that is the basic approach here. Yeah, now this is the most interesting part of this research. I used all these algorithms like random forest and TF, IDF, and logistic regressions. And I also applied n-grams technique, SVM, LSTM, RNN, and BERT. So based on that, I compared it using by drawing a simple histogram, and this histogram is scaled logarithmically because the difference wasn't much noticeable before scaling. So all of the algorithms performed very well, but the best performance was shown by BERT. So that's why I used BERT algorithm, because the highest accuracy it gave was 96, and the lowest one that I got from one of the models was 95%, 94.8%. So that's why I selected BERT. And like I combined all these four sub models for each and every problem, like predicting racism, sexism, body shaming, and all. And I combined it using that simple prediction logic that I already explained. Now, another interesting observation, and this is the conclusion of the project actually, is that the thing was that I was limited by technology. Like the maximum available RAM was 12 GB in Google Colab in the free version. So that's the thing. But despite that, the model performed very well. One thing that I noticed here was, one thing that I noticed here was that when I reduce the number of epochs and for a larger data set, the model gave the very well accuracy of above 90%. The reason being that the data was already large. But in case of smaller data set, when I increased the number of epochs, the model was performing very well, because when each epoch, like when the model passes through one epoch, it is entirely going through one single data set one at a time. So it is passing and learning from all the samples, and when we repeat it, the accuracy increases. So in case I would have used a larger computational capacity, then I could have increased the number of epochs. As you can see, the number of epochs here are 2, and the batch size is 64. On changing these parameters further, as I had done with smaller data set, the accuracy would have been further more increased. But despite that limitation, the model performed very well. So yeah, now moving straight to the conclusion and future development. So yeah, the data set size was intentionally kept small due to limited computational power. And although the higher number of epochs were performed for smaller data sets, the number of epochs were lower for models with larger data set, obviously because of the computing power. So this prevented the model from reaching the full potential. So if a particular research is funded properly and they are using BERT, then in that case, obviously they can work wonders with the algorithm, because this algorithm is really great. Like with a larger computational capacity, it can even have more accuracy. Now, here's a theoretical limitation here that I kind of already mentioned, that discriminatory comment has not, the definition of discriminatory comment has not been formally established, because the intuitive experience of the data set collector or the author, which is me. So it is based on the my intuitive experience, and ideally this project would be better done in an interdisciplinary setting, because obviously, like as a computer science student, we have limited knowledge of the philosophical implications of terming a comment as discriminatory. So it's purely done on a basis of intuition. And finally, another improvement that can be done is that model is not actually connected to the internet. So the database or the knowledge base of the model is static. So we can see that in daily news, we can see new developments, like something great happens which is considered discriminatory. And for that particular statement, the model should be giving a discriminatory value in an ideal scenario, but my model's knowledge base is static. So the solution of this problem is, we can like to improve this model, we can further use a reinforcement based model when an updatable knowledge base. So the knowledge base would be would be constantly updated, kind of like what's happening with like Chat GPT and Bard. Like they are in a way connected to the internet and they can access recent developments. So that is a actually good solution for this particular problem. So that's all for my project. Thank you for listening to me so patiently. So if you have any questions, please feel free to ask.
No, thanks, Rishabh. So, couple of questions from my side. Have you performed any risk analysis, around your project in case if this, in case if this project is going to be incorporated with any real-time applications?
Yeah, so in terms of risk analysis, like I just did the basic testing, like outside my data test, but like I didn't perform it in a formal sense and document it. So yeah, if that's your question, so no, I didn't perform any risk analysis. I mainly focused on the algorithmic aspect.
Yeah, fine. That's okay. So, and could you, elaborate a little bit more about the implementation, that you implementation in the sense the tools and technologies that you used
Yeah,
for this
yeah,
project?
exactly. Sorry. Yeah, sorry, I forgot about that. Yeah. So basically, I used Google Colab for training as well as like running my model here. So yeah, and the model was the algorithm and the model was coded in Python 3.10, and the library TensorFlow and PyTorch were used. And to run this particular model, like the minimum requirement for running it is that one should have a CUDA enabled GPU, which Google Colab provides. So I actually tried to first train the model on my local CPU, but obviously it didn't satisfy this CUDA requirement. Now, what is CUDA? CUDA is basically like at the GPU level, we are dividing the operations, ML operations, into like multiple atomic operations. So what companies like Intel have done is that in CUDA they have converted certain matrix multiplication operations and programmed them at a hardware level. So that's why these operations, like when we convert a normal tensor operation or a matrix multiplication into CUDA, the time complexity further reduces. So I have done such kind of optimizations. And another thing, like I think, yeah, I have mentioned that particular thing in my report, and it's also worth looking at, is that yeah, the time complexity of the particular BERT model itself has been reduced by this CUDA operation. So normally you can see the complexity per layer is this uh, d times n square, right? Where n square, d is the number of embedding dimension, and n square is basically what for each word, like n is the word length, so it iterates it twice, so that's why it is n square. And now the number of sequential steps is 1. So now because of using CUDA operations, like if I hadn't used CUDA operations, then it would have been further like greater than this value. But because of using CUDA operations, the sequential steps have been converted to O of 1, because operations are happening in single step. And for my prediction logic, it's obviously like both are time constant and space constant, because we are just making like general uh, greater than or less than comparisons, like relational comparisons that we are making. So it's O of 1. Now coming back.
Yeah,
Yeah,
yeah, fine, fine. I think you answered the questions, Rishabh.
thank you, sir.
Thanks, and it looks very impressive. Thanks for the presentation. I don't have any further questions from my end.